This is a question from AQA A-level Chemistry. It is a required practical question from paper 3 and it's based on RPA5. Going to recommend, as always, that you pause, have a go at the question for yourself, then review your answer and see how you've done. Okay, so here we have got propanol can be prepared by the oxidation of propan-1-ol with acidified potassium dichromate 6. We have an ionic equation which is provided and we're calculating the minimum volume in cm cubed of 0.4 molar potassium dichromate 6 needed to oxidize 6 cm cubed of propan-1-ol to propanal. We're given the MR of propan-1-ol and the density of propan-1-ol. So let's have a look at how we're going to work through this calculation. First of all, I need to work out the moles of propan-1-ol. Now we know that that is mass divided by molecular mass. We've not been given the mass, but we can work it out by taking the density and volume. So you can see I've multiplied those together. You can see where the data is coming from. They are collectively the mass and we are dividing by the MR, which has also been provided, telling us that we have 0.08 moles of propan-1-ol. My moles of Cr2O72-, we are going to need to use the mole ratio. 3 moles of propan-1-ol require 1 mole of Cr2O72-, so we're going to divide that 0.08 by 3 to get a value of 0.027 moles. We can then work out the volume of Cr2O72-. We're going to do number of moles divided by concentration. We have got the moles, 0.027, and again, taking it direct from the question, we know the concentration was 0.4 mole dm to the minus 3, allowing us to see that we have a volume, converting into cm cubed as well, so multiplied by 1,000, we get a volume of 67 centimeters cubed. On to part B, reaction done in a pear-shaped flask, but you're completing the diagram to show the assembled apparatus. You don't need these diagrams to be perfect, but there are certain things that have to happen. This has to be sealed, because otherwise things are going to escape. We need the jacket of the condenser that also needs to be labelled. So we are going to show a cross-sectional two-dimensional diagram. I'm going to show my collection down here. I need to make sure that I'm heating the pear-shaped flask, otherwise it's not going to vaporize. And I'm going to have the water in at the bottom and the water out at the top. And I'm labeling the condenser. And with all of those things, I get my 3 marks. That takes us to the end of this question. Thank you for listening and goodbye.